Now exact 7 p.m. on October 18, 2024. The ship still docked at the Philippines, Manila, Philippines capital. It's supposed to leave at 6 p.m. a schedule, but here now it's 7 p.m. still. The ship's still here. I think the main reason for that is this morning the ship supposed to be docked at 8:30 a.m. and tourists so to get off at 8:30 a.m. But something with the immigration, something in Philippines cannot finish the immigration task, so the tourists had to get off the ship around 10:30 a.m. So about 1 or 2 hours late. So that's why now 1 or 2 hours late to depart from Philippines to Guam. So that's the reason. So now the ship now is 7:05 p.m. on. Oh, the lights still up now. So that's why the ship still 1 hour late. The reason for that is the tourists get up about 2 hours late this morning. So for the excursion, they about 6 hours, 8 hours excursion, they cannot return at 6 p.m. So they may return at 7 or 8, 2 hours late. So that's the reason the ship is still late to wait for excursion tourists. Now here they see from Manila. See Malaya. I went to see Malaya, the whole town, go everywhere from museum to theater to police headquarters to the court, everywhere in Manila. But they see Manila come from not too up to date current technology, because the cable, wire cable all over the street, hang over the street, so quite dangerous electric cable, and a lot of car run around, heavy traffic. And that's the main thing, not many motorcycle like Vietnam, but a lot of car, small street. So that's why. But we did the first time we went all over Philippines. We hired a taxi. We got about 4 hours. Yeah, now it's there now.
Good evening, Carnival Panorama. This announcement is for Emily Marcelo. So please contact guest services located on deck 3 forward or by dialing extension 7785. Thank you.
Yeah. After that we stopped by the last stop. We buy a lot of Macau. Macau Ta also. We buy a lot of mangosteen. That's the food I like most. So anyway, this trip very interesting trip, because we eat a lot of food from Thailand, Vietnam, and we went to Malaysia, Singapore, and even here, Philippines. There's a lot of food, still a lot of food in the room to say to eat. So the last the main walk we will stop in Guam, where I stayed there in 1975 when I escaped Vietnam. This one, another side of the ship. That's the bank. That's the Manila by night.
Almost lost us the game today. What if I get to camp but I screw up? Exactly. Mom gets it. Yeah, that's so. Singapore dance.
And turn the right hand. You place the other hand at the back. Great, so now you can do that. Right, back to your room, to your husband. What's wrong with you there? I'm alright, you chose something. Now, next we are gonna say thank you and welcome, or we call it Sambah Salam. Alright? So it is a universal sign to do this. We have this in Thai, Indian, Sawadika, Namaste, Vanakam, and that is also a universal sign on saying Thank you and welcome to our guests. Salam, Sambal Salam. Here we go. With an open heart, we welcome you. And thank you for coming. Alright. So, when your wives allow you go to casino, you do this. Thank you, love. Alright, let's do it again. Alright. Thank you, welcome, and thank you. Yeah, I like that. Alright. So, it has been our custom when we were reading or when we have our elderly in front of us, we do not just walk in front of them, dash across. For example, if he were to, I'm the elderly lah, huh? He would just walk across. Hey, I'm watching the TV. Yeah. So this is what we do. We call it tumpang lalu, which is we will lower our back, place it to the back, and walk across. Say, excuse me, I'm walking through. I'm going through. But of course, if in Singapore we don't practice this on the public transport, I'm coming. Yeah? Alright, so you can do that. But I hope that you won't do it at the dining. It's like, excuse me, I want this. I want chicken. No, you don't have to do that. Alright? Now, another way, we don't usually point with our index finger. We used to practice pointing with our thumb. So it's showing direction. Oh, where's the toilet, Dee? Ah, thank you so much. So it's like showing the direction, and then you point with your thumb instead of your index. Yeah. Alright. So honey, where's the casino? Oh darling, it's over there. Alright, so let's try from the first one. First one that we have, which is, how are you? I am fine, thank you, lovely. Welcome and thank you for coming. Terima kasih. And next, we have the, excuse me, I'm walking through. You can practice this on your way back, or maybe later outside, exiting out. Alright? And, oh, where's the bar? Yeah, there you go, it's at the back. Alright. Good. Now, it is also back then in the olden days where the man is always the lead for the hearing about our places of interest of a historical area in Singapore, which is nearby to the harbourfront port. So this place is historical as part of last. Singapore was with Malaysia back then, so this was part of Malaysia as well on Teluk Belanga. So we have the known song which is known as Zapin Teluk Belanga, and these are the videos that we have around the world. So this is the composer, Mr. Zubair Abdullah. Peace be upon you. Amen. Hati redup sayu sarjana mata memandang. Hai teluk berangan namanya tempat bersejarah laginda rakyatnya bersatu budi bahasa negara. Siapa memandang pastikan tertawan liu senyuman si gadis rupawan.
Ship. Anybody see that land that we're passing on the starboard side of the ship? That is part of it. Or a date for yesterday, we talked about the Pacific Ocean, largest ocean on the planet. These are called Mercator maps. And Mercator maps, unfortunately, don't show the correct size. Because if you remember, I told you the Pacific Ocean is the largest ocean on the planet, and that it can hold all of the continents. Does that ocean look like it can hold all of the continents? No way. These maps are not proportional to the sizes. They're basically designed just to show all the land masses. And what happens is, as you go up, as you get closer, on these types of projections, as you get closer to the North Pole, everything gets bigger. And as you get closer to the South Pole, everything gets bigger too.
Oh.
Because of that, look at how big Antarctica is. Huge. Is it really that big? No. No, of course not. But they get bigger, and these projections are basically just to kind of give us an idea of where the relative positions of the land masses are and the oceans. All right, enough of that. 30% of the planet's surface covered by the Pacific Ocean alone. And animals are moving through this. Now, in this talk, we're going to pick out a few specific animals, and we're going to talk about how they move, and we're going to talk about why they move around. This is our migration, right? We're covering, we're migrating right now. Yeah, we're covering 10,000 miles. It's going to take us 18 sea days. We're spending a few times. We're going to land a few times, as we already have. But in terms of just our movement, it's going to take us 18 days. If you were to walk it, it would take you at about 3 miles per hour. It would take you about 140 days. Without stopping. That's walking 24/7, not stopping. But what about animals who travel the Pacific? How do they do it? We're going to talk about our first animal. This is a gray whale. And gray whales have the longest migration of any animal on our planet, any mammal on our planet, I should say. And they migrate between the Gulf of Alaska and then all the way down here to Baja. And they can travel 10 to 12,000 miles. That got cut off on the main screen. They're 10 to 12,000 miles round trip each and every year. Gray whale range looks like this. They have all of this area here. You've got a western population here, about 26,000 individuals, and then we are an eastern Pacific population, and then we have a western Pacific population of about 200 individuals. Now we're going to talk about one whale here in particular. Her name is Vivara. And Vivara is special. She's one of the western Pacific, one of those whales that's over on the Japan side. 9 years old, spends her summers feeding in these islands right here. And then the normal migration would be for this whale to come over here to the Gulf of Alaska. And here are a couple of her migrations. This yellow is showing her summer migration down to here, and then the orange is showing her migration back over here to these islands. And a couple of other whales were also involved in that. That is a long migration for this whale. Instead of stopping in this area, Vivara ended up going all the way down to Baja. Never been recorded before. That was in 2010. Instead of traveling that usual migration of about 10,000, Vivara traveled almost 14,000 miles. And that is the longest single mammal migration ever recorded. And why she did that, we're still not sure exactly why she covered that extra large migration. But we're starting to see some even longer migrations from these gray whales. This is their normal migration. Once again, they're coming here, Gulf of Alaska, some of the Western Pacific, they're up here in the Chukchi Sea, the Bering Sea here. And why are they doing this migration? They're doing it for food. They swim north because this is where the rich Bering Sea, this is where all the krill is. This is where all of their food sources are that they're eating. And the gray whales are eating something different than the humpbacks. And how many people have been up in Alaska and seen the humpback whales? Up there, yeah, they're up there, they're chasing that krill. These whales the gray whales are a little bit different, as we'll see. Their feeding behavior is not the same. And what gray whales are doing, they're eating food that's on the bottom. They're eating crustaceans, they're eating amphipods, they're eating shrimp that are on the bottom of the ocean. And because of that, different than humpback whales that are feeding in the open ocean, these guys are feeding on the bottom, and because of that, they're going to be hugging the coastline as they go up. And these gray whales, just like we're either right-handed or left-handed, these gray whales are either left-sided or right-sided. And you can see that because after they age, you can see the marks from scraping the bottom of the seabed to get their food. And you can see this whale here happens to be left-sided. And they're going through that mud. When they come up and they're sifting through that mud in their mouths, they're going to leave a trail of mud behind them on the surface. But that's what those guys are after. They're going to be eating at almost a ton of food in a single day. And this is important because the entire time they're traveling, they're not really feeding substantially. The gray whales, they're on their way up north, they're on their way up south. They'll grab a mouthful of food every now and then, but for the most part, they're going up north, they're going to feed, and then they're going to come back down south, and that's where they're going to be mating. They travel to the lagoons here in Baja. There are several. Has anybody been here, by the way? I'm always curious. Have you been and seen the whales? Just a few people have been there, seen these whales. They come down here to mate and also to give birth. Just like in Hawaii, the humpback whales are coming to Hawaii to give birth and to mate, and this is where the gray whales go. And there are a couple of lagoons here, Guerrero Negro, San Ignacio, and Magdalena Bay. These are three. And if you haven't had a chance to do that, if you have a desire to have an encounter with whales, these are very unique encounters down here. You go out into these lagoons, and in little boats, there might be 10 or 15 people in the boats, and you're going to float out in these lagoons and wait for whales to come up to you. And these whales, if they want to, they will come right up to the boat, and they'll kind of come out of the water, they'll roll over, they'll look at you. I had a mom push her calf up to the boat one time, and the calf rolled over and opened its mouth and wanted me to scratch the baleen inside its mouth. Crazy, huh? But these whales have been doing this not just for years, but for decades. And some of these naturalists that work in these lagoons, they've been doing this for 40 years, 50 years, their entire career. Pretty amazing. Once again, it's in those three bays that are down there. They're coming here to make babies. They're coming here also to give birth. You've got 4 whales that are in there around that female right there. These babies, they'll stay with their moms for few months, they'll nurse on milk that's 50% fat, and they'll stay with the moms there until it's time to migrate back up north, and then they're going to head up there. The moms are going to guide the babies up there, going to guide them back again, and then after that, those babies are on their own. Long migration. Now, how do they know where to migrate? These whales are going to follow the coast, unlike the humpback whales that are not following the coast. And the mom is going to teach the baby how to end up there. Now, every now and then, following the coast, we've seen a few examples of where these gray whales have taken a wrong turn. And we had 2 different grays that were spotted off of Europe and Africa, which is not their normal range. And we're not quite sure why that happened. There is some research that is beginning to study whether there might be some sort of magnetic compass, because we don't really know how the humpback whales are able to make their way up to the Alaska, the Gulf of Alaska, and Southeast Alaska, where you may have seen them. And we're thinking there actually might be a correlation between these magnetic storms and these whale beaching events that have taken place here. And we're still studying that. And we're thinking there is some evidence or some data that shows there might be a correlation to that. New migration distance recorded for gray whales. We're seeing these whales go all the way to around South America. We've seen them in some bays. The 16,000 migration is one that we may, that we're still trying to understand exactly where this whale came from, but we're thinking it came from that western population and came all the way around. This is where some of these mortality events, strandings took place. This was in 2018, 2019, and during that particular time period, there were solar storms that were taking place, and we're thinking that there might be some magnetic orientation that is taking place in whales as well. We're going to see that in a few other animals. Now, when it comes to animals that are making the longest migration, the Arctic tern is the record holder for this. They have the longest migration of any animal on the planet. 44,000 miles is sort of our typical, but we've seen records set now that we have new technology that enables us to track these animals better, little microchips. We've been recording migrations up to 60,000 miles, and we think last year the longest tern migration is over 70,000 miles. And remember, this is in 1 year. 44,062 last year. It was over 70,000 miles. And scientists are wondering, of course, well, how are they racking up these miles? Because these animals are traveling from the North Pole to the South Pole. They see more sunlight than any animal on the planet. They're going back and forth because they're seeing a long summer up north, and they're seeing a long summer down south. And they are migrating once again for nesting and then for feeding as well. A 30-year-old bird, as an example, will have flown well over 1 million miles in their life by the time they're 30. And the reason they rack up so many miles is because they don't fly like an airplane where they're going from point A to point B in a direct route. These birds, that's what their path looks like. And what they're doing is they're following the wind, and they're gliding on these wind currents. So rather than battling the wind, trying to get all the way down here, these birds are flying in these zigzag patterns here, and they're following those wind currents. And because of that, they end up with these really, really long flight distance. They're going into the Arctics, either the northern region or the southern region, but one hemisphere, of course, not enough. This is what they look like. They're up here in June, and they're down here in January, basically. And both of those are those summer months in the Arctic, in the Antarctic. They're following the food and they're following the wind currents. Here's another migratory bird. This is a bar-tailed godwit, and they have the longest non-stop flight. They can fly without stopping for anywhere from 8 to 10 days, non-stopping, stop. And they're going from one point to the other. So they start down here, they're nesting in New Zealand, they fly all the way up to China, over to Alaska. These are shorebirds. They're not eating during that time, and they're coming up here and they're going to be eating their favorite food are brittle stars, these tiny little brittle stars. And they go into these mud flats. And because Alaska has such high tides and low tides, it can be anywhere from 20, some areas up to 30-foot tidal shifts here. And they'll get on these mud flats, sandbars, and this is where they're just eating. Now, these animals, when they do that flight, say it's a 10-day flight, they're in the air for 10 days. They're able to sleep by turning their brains off, but they just take cat naps of about 30 seconds. And they'll turn their brain up. Our cat naps tend to be longer than that. But they'll turn their brains off, and this is how they'll sleep. The other thing is they're not eating. They do something called autophagia. And what autophagia means is that they will, before they fly, they're going to start gorging. They're going to do what the bears are doing before, it's called hyperphagia. And hyperphagia is what we do on the last day of our cruise. It's when we go up and we're just going to eat everything in sight. Not because we're greedy, it's just because we know we're getting on an airplane and they're not going to give us anything to eat. So we're going to gorge up, and these bear and these godwits will do the same thing. And we've taken blood samples from these birds. And if the blood sample was coming from a human, that human would be dead. The cholesterol is off the charts. Blood sugar, off the charts. You would be dead from this. Because these birds are eating everything in sight. So they've just built up all of these food reserves, and then they take off. And they're not going to land for another 10 days for a fuel stop. They're going to burn through all of that fat that they put in their bodies, but they're not only going to burn through that, they're going to start doing something called autophagy, and this is where they begin to eat up their internal organs. They're going to eat their stomachs. They're going to eat their liver. They're going to eat their intestines, and they literally self-cannibalize until they get up to Alaska. And now the blood chemistry looks entirely different. These birds have literally eaten themselves from the inside out. And now they're going to land on that mud flat, and they're just going to start eating like crazy. Within 1 week, everything is back to normal. They're just like a normal bird. They regenerate those organs that they've been eating, and now they're just going to hang out there, and they're just going to eat until it's ready to fly back home again. They're going to make a short pit stop here, and then they're going to head back to New Zealand, where they're going to nest and begin that cycle all over again. Another cool bird, these are sooty shearwaters, and as we get closer to Hawaii, we're going to start looking for these birds. Has anybody seen that bird that's been following us here for the last 3 or 4 days? Have you seen a bird kind of gliding out there? That is a brown booby, B-O-O-B-I-E. And that is a seabird. These are migratory birds, shorter distances. We're going to see as we get closer to Hawaii, this is the booby that's out here. It's the brown booby. And as we get closer to Hawaii, we're going to start seeing another species of booby, and this is the blue-footed. And we're going to look for this. There's a red-footed, a brown, and a blue-footed. Hawaii is where we'll start to see these really cool birds, the blue booby. But in the meantime, these sooty shearwaters are found all over the world, and they have a migration that they do as well. Once again, they're down here in New Zealand. They're going to be up here, spend most of their time up to the north, feeding during the summer. During the October time frame is when we start to see these birds coming back. And also, just in general, depending on where you are, whether you're from Australia or you're in the U.S., during these migratory periods of time, There are literally billions of birds that are flying over your head and you don't even know it. Scientists now are beginning to use Doppler, which was originally created to help us predict the weather. But now the Doppler's gotten so good that we can see birds migrating. And not only can we see birds, but we can also see what species of birds those are by using this Doppler. And there are literally billions of birds that make a migration from the north and south without us even knowing it. Those lights in New York City that are commemorating, they're on the 9/11 monument, they will, based on Doppler, they will turn those lights on or turn those lights off during the migratory season because these birds become disoriented from the light pollution in their migration. And when the Doppler hits a certain point, they use it, they will turn the lights off at that memorial so that those birds can continue that migration. And then when the Doppler system comes down, then they'll turn those lights back on. But that's how many birds are flying overhead. These birds have the second longest migration on the planet. How do they do it? They do it by smell. These birds belong to a group of birds called tube-nosed. And tube-nosed birds will excrete salt from these little tubes. They look like little tube nostrils that are right above their beaks. And these birds don't drink fresh water. And every now and then we'll have bird. Has anybody had a bird land on their balcony, by the way? I was talking to a couple of guests the other day that they had a snowy egret that was on their balcony. And if you do have a bird that lands on your balcony, just call guest services and let them know, and I'll come by or somebody else will come by and we'll release that bird depending on where we are. Like, you wouldn't let a snowy egret go here because it's a shorebird, so we would wait until we got to an appropriate place. But in any case, these birds do not drink fresh water and they don't eat Cheerios. Because every now and then I'll see somebody put, like, they'll see a bird, it'll be stranded, and bless their hearts, they're doing it out of the goodness of their hearts. They care about these animals, and they'll put a little bowl of water and a little bowl of Cheerios out for these birds, or something, some kind of food that they think they eat. But these birds do not drink fresh water. They get their fresh water, even if you put it there for them, they're not going to drink this water. They don't know what it is. These are seabirds, they live in saltwater environments. And so they'll eat food, sometimes they'll bring salt water into them, kind of not drink it, but it'll get into their systems. And then what they do is they have desalinization plants built into their bodies. And they will they'll get the fresh water from the foods that they're eating, and then the salt will get excreted through these little tube noses. And we used to think that that was the primary purpose of those two little openings above their beak. But now we know that the most important function of that is smell. And these birds are designed so that they can smell tiny, tiny parts per million of smell. Something that we would never smell. And these smells will drift on the currents, the wind currents that are coming from thousands of miles away. And of course it gets more and more dilute, the scent molecules that they're looking for. But just 1 or 2 parts per million these birds can detect, because that is what it requires for them to survive, and they've developed this mechanism. And these birds know where to go. For example, krill will give off scents. These are protein-based molecules that they will give off when they're in those huge numbers, and those will get picked up by the wind, and then those will get carried thousands of miles away. And these birds have the ability to detect 1 or 2. Off to the left, there won't be any molecules. Off to the right, there'll be a few molecules. And they'll orient themselves to follow those for thousands of miles, and that's how they end up finding their food. And although we don't know how humpback whales do this, and we know humpback olfactory senses aren't really well developed, I think that eventually we're going to discover that this is also how humpback whales find their food. Toothed whales, like orca or sperm whales, they can send out sonar. But humpback whales or all the baleen whales, they don't have sonar. And we're not quite sure exactly how they find their food yet. But I'll bet anything that it's going to end up being smell. Because they have the ability to smell. Now also, here's another animal. This is a leatherback or loggerhead turtle. And these guys also have a migration. They have their nesting populations that are located in these different areas here. How many people have seen these turtles, by the way? Maybe even green turtles. Seen green turtles? All right, these are loggerhead sea turtles. Population about 60,000. These are some of their nesting sites in Australia. This is Queensland up here. These are on the Great Barrier Reef. They have this concentration. Here, also up here, we've got these two curds that are coming up from the Australian area, and this is the life of a loggerhead turtle. And it begins in these warmer waters, these sandy beaches. After hatching, these turtles, they have to run through this whole gauntlet. They have to try to get to the ocean. And once they are able, if they are lucky enough, only 0.1% of these animals survive. So the female is going to be laying a lot of eggs. They're going to spend the next 30 years of their lives navigating and managing the Pacific Ocean. And they are not going to come back to nest until they're sexually mature. And depending on the species of turtle, this can take anywhere from 10 to 15 years with the loggerheads, up to 30 years. And they are going to begin migrating and moving through feeding grounds here. James Cook University, they found that they will ride the EAC. How many people saw, wasn't Finding Nemo? Yes, it was Finding Nemo. Then we had Crush, yes. And he traveled, that's right. And he traveled the EAC, didn't he? And you got to see that. How many people have seen that movie, by the way? Finding Nemo. If you have grandkids, even if you don't, you will have seen that movie. Disney has done a great job with their animation, and they study for years these animals. They get it pretty accurate. So the EAC begins their journey from Australia to Chile, and you see this loggerhead, he's got something funny on his shell, doesn't he? He's got a little transponder, and we're going to use that to track his movements and see exactly how he does that. There's good old Crush here. So we track this guy, and if you look, you'll have to see this on the side screens. They cut off my main screen here. But if you look, you can see that traveling all the way to Chile, back, ends up spending time in these feeding grounds year after year after year until some biological signal says, okay, it's time to go home and finish your life cycle. This is that route again. You can see how that transponder. This is another loggerhead. These guys from Japan will travel from Japan, and then they're going to spend their time off the Baja coast, where they'll be feeding for years and years until it's time for them to return back to Japan. Loggerheads, they've also been seen up in Alaska as well, feeding. How do they do it? Well, these guys have two mechanisms. They have a magnetic compass that is built inside, and this magnetic compass is how they orient. And we're pretty sure that they do it this way because we have done experiments where we've disoriented or disrupted that compass, and then we've also had tracked their course and played around with that a little bit in a contained environment as well, and seen them moving, orienting themselves according to the magnetic direction rather than the actual place that they've been going. They also have, loggerheads have this thing called a pineal gland. We all have this, and this is what will orient our circadian clock. And they also have that. So we think that they will use this. It's a little area, you can see it where that circle is. It's a little light-skinned area that allows light to go through and strike their pineal gland. And this we think also is what helps them know when the light begins to be reduced, they know it's time for them to move on and to move on to their migration. And here you can see an example. We disoriented this turtle in a controlled environment, and it swam north, and when we reversed it, it swam south. We know that they have some kind of mechanism to orient themselves to the magnetic lines of the Earth. Turtles knew exactly where they were supposed to be based on that magnetic information. How they do it exactly still remains to be seen completely. They've been known to mistakenly nest at beaches with similar magnetic fields, even as far away as the Florida coast. We know they're following those magnetic lines, and we know that when we have magnetic storms this year, as you know, we've been having a lot of solar activity that's been affecting our magnetosphere and changing those lines a little bit, and you can bet that there are scientists out there studying this and how it's affecting animals that are migrating. And that's just a little diagram of that. Now, here's another animal that migrates. Not as far. These are
Right.
the Christmas Island crab. And they look like that. Going back, you see that migration? There are literally millions and millions. Has anybody ever seen this? No? All right, we're going to look at this. This is about crabs on the move. This is Christmas Island, discovered by Captain Cook. Spent Christmas there on one of his voyages, and that's what these guys look like. First rains of the wet season, these guys move to the beach. And it's all the males are leading the way. The females are going to come in a few days. They'll close the roads. They have bridges for these crabs like that. We're starting to do more and more of that, developing for animals that move from space to space. We're starting to build this over our freeways even. Well, they built it for these red crabs. The roads close and these animals come out. Now, these are land crabs, and they're a little bit different than crabs. You got crabs that live in the ocean, and then you got crabs that live on land. And the crabs that live on land, you might be wondering, well, how are they able to do that? Crabs always live in the water. But these guys have special lungs. They're kind of like gills, and they're designed to take oxygen out of the moisture that's in the air. So they're not breathing air, they're still breathing water. But they're found in areas that have high humidity, and that those water molecules will land on those little areas that are more like gills and lungs, and then they'll pull that oxygen out. So they have to stay kind of moist. Well, by the time they get to the beach, they're 8-9 miles inland. They're going to jump in the water. They're going to get those gills moist. They're going to pull oxygen out of it. Males are going to build the nests, little burrows. And then the females are going to come along a couple of days later, and then they're going to fertilize those eggs. That female is going to carry those eggs, and when the next high tide comes, they're going to head out to the water, and that's what they're going to do. And they're going to spread their eggs by the millions out into the water. Then these eggs are going to hatch. They're going to develop into these tiny little these tiny little crabs. They're actually born pretty much like that. And then those crabs are going to make their journey. They're going to migrate back inland again, if they're lucky enough. And then they're going to hang out there for 2 or 3 years until they're mature. And then they're going to start that journey all over again. That's another example of migration. Pretty cool. Another animal that migrates. Haven't people been to Alaska again? Done all that? Yeah. These are the salmon. Have you seen salmon?
Yes.
Okay, cool. There are 5 different types of salmon that we know of. All these salmon are born in freshwater and they migrate out to saltwater. That migration helps feed the oceans. The king salmon is the salmon that makes the longest migration. Pink salmon have the shortest. They're born in freshwater. They go out to the ocean for a year and they come back in about 2 years. King salmon or Chinook salmon, they're the biggest salmon. And they actually spend a couple of years in freshwater, then they go out for 3 or 4 years, and then they come back again. And these guys are the biggest of the salmon. Young salmon freshwater, they look like that. Smolts, they grow, they're an alvin, then they're a smolt, Then they go out to the water, they're going to change color, they're in fresh water, they have to change their whole internal body systems, their kidneys, gills, so that they can manage salt water. Then they're going to travel out. Before they leave, they're going to remember the smell. We know that they use smell to orient themselves.
Oh, they know the way
And
to
they
get that.
remember that. Now remember, their ability to smell is much, much more keen than ours because they need it. Okay? Everybody, and if you think about this, every animal has what it needs to survive.
Yeah.
We don't need to have a sense of smell that is that acute that can pull out just 1 or 2 molecules of what they're smelling. Remember, when we're bringing smells into our bodies, those are chemical molecules that we're bringing in that are activating our senses. Same thing for these guys. So this is a Chinook salmon. He's going to go out into the open ocean, swim around, eating the smaller fish. They're all carnivorous. Open ocean salmon migrate using a magnetic map of the ocean while they're out navigating. And they know where to go based on this magnetic map where all of the prey are. But when they reach the mouth of the stream, now they're going to switch senses and it's going to kick in, and now they're going to be smelling to navigate up that stream. Here's the Yukon Delta map. This is what it looks like. They can swim almost 2,000 miles to reach the spot that they were born in, where they're going to nest. So here's what it looks like. They're going to swim up that. They're going to take a right, going to take a left, going to take a right, going to take a right, going to take another right. And how do they know how to do that? Because the scent molecules, the molecules from the stream of origin, become more and more concentrated. And as they do, that's the path that they're going to follow. They're going to jump up streams. Of course, they're going to have to fight the orca. Here, the super pond that lives up in the Gulf of Alaska, they're going to have to fight eagles. And of course, we're after those king salmon too, aren't we? Bear as well. Finally, once they get there, they're going to create what's called a redd, and in this redd is like this perfect little nest. They're going to lay their eggs here. They're going to build a few of these as well. The male are going to come by, fertilize those redds, and of course, as soon as all of this is done, both the males and the females die. It's a one-time. There are a few exceptions to that a few of you may know of. The Atlantic salmon have been known to do this a couple of times. We know that's possible, but for if you do know this, for all the Pacific salmon, it's just a one-shot deal. But the nitrogen from their bodies, as that decomposes, it also feeds the forest. And we know this because we found salmon DNA even in the trees. That's what that life cycle looks like. They start here with eggs. Those eggs hatch. They have little tiny alevin that have egg sacs. Then they turn into fry, then smolt. And then once they're at that small stage, then they are off into the Pacific Ocean. They're going to do that, swim out, get bigger, and then they're going to come back and spawn, and then the whole cycle starts all over again. This is what alevin look like. We go down here, and that's going to get cut off. The fry, the smolt, the main salmon comes back in, forms a redd, and then it's all over again. That is the migratory life cycle of a salmon. Now, I thought I would add this slide as well, because not all migration takes place horizontally. There's also vertical migration that takes place within the ocean. And this was first recognized, believe it or not, during World War II. We didn't really know about it. This was when we had this sonar, where these ships were able to look at depth, because that technology was developed so they didn't end up on shoals. These ships, especially during World War II, didn't end up beaching themselves. And we were fighting right here in the South Pacific, and as we know, there are lots of shoals and so forth. And these guys start to notice things. They're going, man, this isn't where the bottom is. And they start to see these, we'll have to use side slides. We start to see these different scatterings that are taking place. They're going, well, wait a second, the bottom is here. What the heck is this? These unidentified bands. The original scattering layer turned out not to be the bottom of the ocean, but it turned out to be all of these animals that were coming up. They're coming up to feed, and then they're going down. Coming up when the light is out, they're coming up because we have all this photosynthesis taking place. They included crabs, all kinds of things, squid, smaller fish, fish we've never seen, shrimp, mesopelagic shrimp were coming up with them by the hundreds of billions, these animals. And it turned out, as we studied it more and more, it turns out this is actually the largest migration that takes place of any life on our planet. 5 billion metric tons of animals coming to the surface. This is in the Pacific Ocean. Every day. This is happening in all of our oceans. Now, these areas, of course, we started to see some other visitors, and we were wondering, well, why are all these sharks coming into this particular area? Turns out that's why they're coming, because all of this life congregates in this area. Also, we see this. How far did you travel for a spa day? It's an orca. You saw some unusual behavior with orca as well. This is a type D killer orca. Orca are found in all the oceans of the world. These guys are sitting right here. These are the ones that are in the South Pacific, the Antarctic region here. And of course, life, as we know, is abundant, just as all those whales are going up to the Gulf of Alaska, Southeast Alaska to eat. We've got southern population of humpback whales that are coming down to the Antarctic area to eat. And of course, with those, we also have killer whales up there, just as we do in Southeast Alaska. That's what they're after. All of that krill. Well, all of that krill also creates an environment for these guys. These are called diatoms. And diatoms are algae, except they're very different. Instead of just being the regular algae, they're enclosed in a glass case. And they have all these, depending on the species of diatom, they're the most diverse animal on our planet. They're covered in glass, silica here. And what happens to these killer whales, you can see kind of that greenish color on them. These diatoms will stick under their skin. And because they're in these colder waters, they can't just slough that skin. Like we slough our skin every 7 or 8 days, we have new skin that forms with us. Well, these guys, it's not like that. So they have these diatoms all stuck to the outside of them. And they can't get rid of this dead skin. So what do? They take a spa day, it turns out. We just recently found this out. And they're going to head up to Rio. We call it maintenance migration. And they come up here to these warmer waters. The diatoms don't do well up here. Now look at that. They get this nice, clean, squeaky clean white color. So you can see this kind of yellow color. That's not, you can't quite see that, but that's that nice white color. So they go up there, have a spa day, get rid of all those diatoms, and they head back. And we now have data to show that they are making this journey back and forth, up into those warmer waters. Whale 42 days journey, only to return to the location only 25 miles from our starting spot. They go up, get themselves cleaned off, and come back again. And then they come back, they're in the waters, it's rich with food and so forth. All right, today's final species travels further than any animal that we know of. Our last one. Down to the bottom of the Marianas Trench, we've done vertical migration up to the highest peak, and we've even gone to the moon. What a migration that was. In a sense. And that's on the Marianas here. And I'll challenge you to think about what brings you on your journey here. Think about why you're migrating and why you move from one place to another. There are all kinds of reasons why you move. All right. Okay, hang on one second. Let me end this because I know they've got bingo coming up, and then I'll hop off the stage and we'll chat about that. Today's next show is going to be exploring Guam day after tomorrow, and I got a nature walk on the schedule for 8:30, just to remind you again. And that'll be a chance where we can get together. Tomorrow. I said we're going to be looking for whales. We'll be looking for seals, sea lions, birds, all of that stuff. It also gives us a chance just to get out and walk around. All right, thank you everybody. Have a great day.